Welcome to the Bitweenie series on Altium Designer. In this video, the third in the series, I'm going to pick up where we left off last time, take the schematic, and generate the PCB layout. So let's go ahead, open the software. Here we'll see the schematic that we created from the last video. To begin, we need to import all of the footprints into our PCB. We'll do that by clicking on Design in the toolbar, Update PCB Document Tutorial PCB Doc. It's going to show you an engineering change order for all of the components it's going to add, all the nets it's going to add, everything that's going to add to the PCB document. For today, we're going to go ahead and uncheck Add Rooms. It's a little bit of an advanced feature. Everything else looks good, so we're going to hit Execute Changes. All green check marks, which means everything executed properly. Now we can close. So here's our PCB document here that opened automatically once we imported our components. And if we scroll over, we'll see all of the components are now imported into our design. Here are our capacitors, our voltage regulators, and our 9-pin connector. Now that we have all of those components in here, you may notice that a few of the pads are green, which indicates rule violations. So let's go ahead and take a look at the design rules first. To open up the design rules, we click Design Rules. This brings up the entire set of design rules for our PCB design. There's a few that we're going to go ahead and change for this particular design. The first is under the routing category, width. We can leave the minimum width at 10 mils. And the preferred size at 10 mils, that's fine. But we need to modify the maximum because we are making power traces and those need to be much wider than 10 mils. So let's go ahead and up this to 100 mils for maximum width for our top and bottom layers. The next thing that we're going to need to change is under manufacturing. Here we have some silkscreen elements, the yellow lines that are within the package of our footprint, which is causing errors. It's not actually a problem in our PCB, so we're going to go ahead and disable this rule by clicking on the silkscreen over component pads entry and then unchecking the box. Finally, we're going to modify the hole size here, because we've got large holes in our 9-pin connector and we need to go ahead and up the maximum so that they don't violate our rules. So we're going to take this 100 mil maximum and change it to 150 mils. With those three modifications, we'll hit Apply and OK. And now you can see all of the violations, the green colored pads have disappeared. So now we're ready to bring these components and place them onto our PCB. So this black area over here is the actual PCB area. This is where we want to place our components. If I zoom out a little bit here, you can see the entire PCB. So what we're going to do is start dragging these components onto that PCB surface. We'll start with the 9-pin connector. And this needs to be on the edge of the board. So we'll go ahead and just place it in the lower left corner here. Great. Now we're going to bring our voltage regulators onto the board. Just arrange them how we want them. And we can highlight more than one component at a time, like I've just done with these 4 capacitors, and drag them onto the PCB surface as well. I'm going to go ahead and zoom in a little bit more. You'll see all of these wires, or rather these lines, which indicate how the components should be connected. So I scroll or zoom in a little bit more, you'll actually see the net labels on the components. Now we know from our schematic that C1 and C2 are associated with U1 voltage regulator and C3 and C4 are associated with U2 voltage regulator. So we're going to go ahead and move these around just a little bit in a more logical position. We'll take C3 and drag it over here. C4, drag it over. Alright, so let's zoom in a little bit more and note that C1, pin 1, is to be connected to pin 3 on our voltage regulator. So we will move it right here next to pin 1 and drag the designator off to the side, and then we will take C2 and do the same thing, moving it next to pin 2 and move its reference designator off to the side. Now the traces between these two pins will be kept very short. We'll move over to U2 and do the exact same thing. By the way, when I'm rotating these components, that's accomplished by just hitting the spacebar while you're dragging. Okay, great. Now we have our components placed. There's still quite a lot of dead space in here, so I'm going to go ahead and highlight this entire section and drag these over a little closer. Now if I zoom out, you'll notice that my components occupy a very small percentage of the PCB surface. So the next thing that we're going to do is define a much smaller physical area for our PCB. We're going to do this by selecting the Mechanical 1 tab on the bottom and drawing the actual physical dimensions of the PCB as that mechanical layer. So to accomplish this, we're going to hit the P key, as in place, and select line. Now we're going to zoom in and draw this line on the corner of our PCB. Since we selected the Mechanical 1 tab before we did this, the line's going to be pink and it's automatically going to be on our Mechanical 1 layer. I'm going to draw this line out to what I want the edge of the board to be. Click again, and that line will continue. I'm going to make it straight. Come up to the top. Now that we have the outline drawn on the mechanical layer, I'm going to go ahead and hit Shift S as in single, and since I have the Mechanical 1 tab selected down here in the bottom, it's going to show me just that pink line that we drew now, our mechanical layer. Now I'm going to highlight, which is going to select all of those lines. We're going to go to Design, Board Shape, Define from Selected Objects. Okay, you can see that it cut away all of that extra black background and has now defined our PCB shape according to that mechanical layer that we drew down. Now if I hit Shift S as in single again, you'll see our fully updated PCB at a much smaller size. Now with our components placed and our board shape defined, we're ready to go ahead and route our design. So let's begin with routing the capacitors and the U1 regulator first. So I'm going to hit P as in place. I'm going to hit interactive routing. I will select pin 2. And now I'm going to hit tab, which is going to allow me to modify the width of my trace. Since I want to have my power trace be a little bit wider than the 10 mil default here, I'm going to adjust it to 20 mils. Hit OK. Now you can see my thicker trace connecting between my two pins. I'll hit escape and do the same thing for pin 3 VCC. For my grounds, I'm going to connect them together here like this. Now I know that I intend on making the entire bottom layer of my board a ground layer, so I'm going to go ahead and insert a via between these grounds and that bottom layer. This is accomplished in the same way by hitting P is in place, interactive routing, draw a line out, hit escape, then hit P is in place, via, there we go. Now we'll see that there is a rule violation here, but that's because this isn't fitting the exact dimension set up in my rules for routing vias. If we take a quick look at that, under routing vias, we'll see the minimum via diameter is 50 mils and the minimum hole size is 28. So let's just go back and adjust this. 28 for the hole size and 50 for the diameter. Good. And that makes my rule go away. Now what I can do is highlight this entire section. So I've highlighted the via and the trace and hit Control C for copy and click right on the pad, then hit Control V and I can paste it right over for my other ground. You can even hit Control V one more time and paste this down for pin 1 on my voltage regulator, which interferes a little bit with my reference designator, so I will drag that down a bit. Final piece to route this together is to hit P, interactive routing, and route my 1.8 volt pin 2 to the tab on my regulator. Okay, so let's go ahead, move over, and do the same thing for U2. Since I've just copied this via and trace to ground, I'm going to go ahead and put those down for C3, C4, and pin 1 on U2. Move the reference designator. Okay. P, interactive routing. Bring that down here, and then up to the tab. And then finally, moving VCC down to my pin. Okay. One thing that you'll notice here is as I start to connect the nets up, the little lines connecting them will disappear. Though you'll still see lines between, oops, I forgot the grounds here. You'll still see the lines between these grounds, and that's because I don't have my ground layer placed yet on the bottom layer. Once I have a continuous ground plane on the bottom layer, all of these lines will disappear. So we can go ahead and do that now. The way we accomplish that is by selecting bottom layer and hitting P as in place, and selecting polygon pour. We'll bring up the polygon pour window. Now we need to select ground as our connect to net. Some of these other options are a little bit more advanced and we're going to leave them for now. But we also need to make sure that bottom layer is selected right here, and it is. So we'll select OK. And now we'll draw our polygon pour by clicking in the four corners of our PCB. Once the four corners are selected, hit escape, and you'll see the blue fill-in region here. Now, if I select back to top layer, you'll see all of these components, and all of the lines that were connecting those grounds have now disappeared. Our final routing step is to wire up our connector. Let's begin by wiring up the 1.8 voltage. We'll hit P, select interactive routing, and draw a trace directly over this gate. Now we're going to do the same thing for our 3.3. This time we'll take a little bit more roundabout path. There we go. VCC now. Route around these components. And we can connect these two VCC pins together, and finally make our VCC connection over on U2. Let me just say that this isn't necessarily the best design. This is really just meant to be an instructional video on how to do routing. In the future, perhaps we'll cover how to optimize this design. Looks like I'm missing this trace right here as well. There we go. So if I zoom out, a little too much there, you'll see all of my wires have been connected. There are no more lines between any of the components. So I will save my PCB, and then I'm going to do a rule check. So tools, selecting tools from the toolbar and hitting design rule check will allow me to execute a design rule check which will identify any issues with my PCB. So run design rule check. Okay. You'll see that I have 0 errors or 0 warnings and 0 rule violations here. Go back. My PCB is fully routed. There's just one other modification that is a pretty common practice, a great thing to do. So let's select top overlay layer and hit P. Select solid region. And we're going to draw a box just like that. Escape. Draws a yellow box. And we're going to highlight it, Control C to copy it, Control V to paste it. Okay, then hit P once again, select string, hit tab, type rev, and hit tab again, type S/N for serial number. There we go. That's just an all-around good practice for your designs. Oh, one last thing, we have J1 here floating off the board, so let's go ahead and bring that back onto our PCB. This concludes our PCB layout tutorial. Stay tuned for the follow-up tutorial where we'll take a look at more advanced PCB layout features. And if you're interested in more videos like this, or those on DSP and FPGA, please check out bitweenie.com. Thanks.